Hey everybody, this is Larry. This Code Daily Challenge. If it ever wants to load, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm and your weekend coming up. Let me know if you're doing anything exciting this weekend or whatever. Uh, a little bit sad today because the Knicks lost. But they're still up. They should. I don't know if they should have won, but they could have won, and it was just you know up by 9 with 9 minutes to go. You have to be able to win that. But it is what it is. The NBA playoffs are crazy these days. So yeah. All right, let's take a look at today's farm. 857 minimum cost to hire K workers. There are N workers. You're given two integer arrays quality and wage, where quality sub I is the quality of the ith worker and wage sub I is the minimum wage expectation of the ith worker. We want to hire exactly K workers to form a paid group. To hire a group of K workers, we must pay them according to the following rules. Every worker in the paid group must be paid at least their minimum expectations, wage expectations. In the group, each worker's pay must be directly proportional to quality. Okay, what does that mean? If the quality is doubled, they must be paid twice as much as the other worker. What does that mean exactly? Oh, so basically, if in this case, if you just do 10 and 5, and that means that, wait, what? Oh, yeah. Then because this has to be 70, that means that this has to be 75. Okay, fine. Okay. I think I understand the problem. So you have to pick K of them, right? The first thing I would think about is that something about quality. I mean, the first idea that I have is actually something about binary search, but I don't know that I have one that makes sense directly, to be honest. But quality, right? I mean, the way that I see it is that I'm trying to think whether do you want more quality or do you want less quality, right? But the wage limit is also a thing. I'm trying to, in my head, trying to conflate all these things together into one cohesive understanding. And to be honest, I'm not quite there yet. So having, let's say we do sort this by quality, right? What does that mean? That means that we have 5, 10, and 20, and then this is like 30, 70, 50, right? Does that even change anything? So what I think, to be honest, I think I'm still struggling a little bit about how to um, define it more concretely, how to pay a group of people in general, right? I mean, I get that you have quality, so basically, how I would think about it is that I would sort by the quality. Would I? I think I'm trying to figure out ways such that you only need to calculate it once, and not, you know, and is it do? And there are really only four ways to sort it, right? It's either quality in two directions and wage in two directions. And I'm not convinced that I see it makes sense either way. But let's say the requirement is 30 and 5. I'm trying to also try to figure out. Okay. I think there is a way. Well, okay, actually they said it this way, but I think I read it incorrect, or I didn't read it in a way that made sense. So then, okay, so let's say you have quality, right? Such a weird problem. Let's say you have quality, so you have a sort of total quality, and then how does that relate to wage or minimum wage, right? And let's say we have, I think one idea that we can think about is like this replacement thing, and whether we can kind of get at it, right? So basically here we have 10 and 20 and 70 and 50. So then now the cost is going to be 70, and then this is double, so this is going to be 140, right? So that means that it's like 210. So then you have 5 and 30, and do you want to replace the 20 and 50? Is it just like a quality over wage thing? I don't even know. What is the limiting factor? Huh, this is a hard one. I'm not gonna lie, I don't know. I don't have a great idea about this right now. Maybe I'm looking at this too much. Let me take a look at another example. What is the limiting factor when you have a group of people? Is it always the person with the lowest minimum wage? No, right? Because here it's 30, and that's still that's not the. Is it the highest minimum wage? No, I mean in this case. Or is it a ratio? Right? Do we sort by a ratio? I mean, I guess that's the other thing that I didn't take account. But the thing is that it changes the cost of everything. So does the ratio change? Like, okay. So for example, this is 1/7. So you have 1 quality per 7. You have 2/5 and 3. Actually, no, 1/6, right? So okay. Usually I do this on paper, but obviously I'm trying to show you people at home. So yeah. So then you have 1/7, 2/5, and then 1/6, right? Does it matter if we just sort by here? So then we get one thing per quality. But that doesn't make sense here, right? Because we don't consider the 1 and the 8. This is 1 quality per 8, which is actually pretty crappy. Because do you want more quality or lower quality? I can't even tell, to be honest, with this farm. I think that's the part that I'm really struggling with, is that if this is greedy, and I don't know that this is greedy. I looked at constraint very briefly. It's 10 to the 4, so it's not going to be like n square. So we probably even need to do it a little bit smarter. But yeah, if this is greedy, like I don't see an obvious idea. Right? I mean, I think I just need to play around with more. I mean, I try to think ahead and skip ahead, but I'm failing. So what I'm trying to do now, or going to do now, is try to think, just work through some examples and getting the feel. Because I think the idea that I usually am is, or try to get, is just like some idea of, just like feeling the problem out. But and maybe I spent too much time on this one, where maybe it's just not a good example. Maybe this one's a little bit better. I don't know, right? So okay. So then let's say we have 3, 1, and 10, right? So then now the total quality is gonna be 14, and then you have 4, 8, and 2. This one makes it so. Is this the usual? I guess so. So you take the minimum element, and then in this case it's gonna be 1. So that means that this is 3 times more. So 8 times 3 is what, 32? No, 24. I can't do math. And then the other one is just 80, right? So that's gonna be like 112. but but the one thing is not always limited, right? Because in the other case you have like if the cost is 1 and you have, say, the wage is 5, and then the next one you have 10, and then the wage is 100, then in this case it's not going to be, if you just do the math, it's not actually 50, it's actually by 100. So what is the limiting factor for, is it the is the limiting factor the lowest quality per wage? Is that the limiting factor? What was this again, 2? Because then now this is limited by the 1/8, right? And what I like to do is I like to validate my ideas with other thingies, right? So here I'm going to go back to example 1, and now we have 10, 25, 70, 50, 30, and then now if the same idea is right, then the limiting idea is going to be 1/7 here, right? 1 quality per 7. So that means that the lowest quality per thing is going to have the greatest thing, right? So then, okay, now we have to find, I mean, it took a while, right? So I have identified a way to calculate this, which is that if you're given the ratio, the lowest ratio of quality over wage is going to be the limiting factor. At least this is, and the reason why this is the limiting factor is because that is the determinant calculation, right? Because now, let's say you have this thing over here, and you take 2. Let's say these 2 because I think that's the answer. And then now, as we said, we have 1/7 and 1/6, and then the idea is that now we can determine that the total quality is 15. That means that the total cost or the is it? Yeah. The total quality is 15. The cost is 1 quality for 7 units. So then it's going to be 15 times 7, which is, I guess, 105, right? And so now another way to think about it is that now we're trying to minimize this ratio inside the group that we picked, and outside the group that we picked, it actually doesn't even matter as long as the ratios are higher, right? So then now another way of phrasing it is that given these ratios, what is if you sort by the ratios, then it is the kth smallest ratio, right? Because then now, in a greedy kind of way, if we determine the limiting factor, the limiting factor of the calculation is based on that, then we can just do it that way. So okay. So yeah, that makes sense, and then that's it. Okay, yeah. Okay, this is a kind of tricky one to really understand, to be honest. I'm going to explain. I mean, I actually think I get it now, but now we have to explain why, right? Because basically, the thing that I was struggling with is that how do you calculate this 105 value from this without, like, some n square loop? And then now the idea here is that if we look at the ratio of quality over wage, and because we have total quality, and because the minimum wage per quality is going to be the lowest one, meaning that you have to pay the most wage, then you already have total quality, you have the quality per wage, that's enough to get the minimum wage. And then now you have to minimize this, and by minimizing this we choose a greedy kind of way, right? Because basically we're saying we want a subset of this such that we minimize the ratio of quality over wage. And of course, in a greedy way, if we just sort it, or I guess you use a heap so that you could do it. And I'm not going to do that, but I'll show you how in a second. But I guess we could do it. I don't know. It's not a big deal for me to go down from n log n to n log k. I mean, for an interview, you definitely should. I'm just being lazy. I don't know, to be honest. But yeah, okay. So yeah, okay. Yeah, they're the same size, right? They should be. Otherwise, it would just be very awkward. Okay, so then now you have, I don't know, I'm just going to buckets because I'm a little bit lazy. So we want to sort it by, yeah, quality over wage, right? And now all we have to do is, so buckets sub k of 0 over sub 1, that is going to be the ratio that we care about. And then now we just have to get the sum of the total quality that we get, right? So this is quality k cheapest, it's like the cheapest quality per wage with k workers, right? So like the k cheapest kind of, but you have to include everyone else, right? So now you have this ratio. So then now you can do for I in range of, was it k? Maybe I'm off by 1, right? So then now we have total quality. I guess I can just write it as sum, like this, right? Okay, fine. Let's write it this way. Something like this. Maybe I'm off by 1. I'm really bad at off by 1. And then, yeah, and then now you have total quality times ratio. And that's pretty much it, I think. I mean, unless I really misunderstood this problem, or just like off by a lot. I am off by a lot. Wow, that is not even close. Am I like weird? That doesn't make sense. Okay. 0.4. Why is this 0.4? This should be. K is 2. So okay. So yeah. This is 1 indexed the way that I did it. Okay. Not quite right. Wait, what is going on here? What do I want? Am I saying this right? Maybe my reduction was a little bit hasty, because this is very wrong. All right, let's just print out. So we have 1617. 17 is bigger than, no, 17 is smaller than 16, Larry. Okay. Yeah, so you have this thing, and then you have. Am I just confusing myself? It's possible. Oh, this is wrong anyway, because I think I'm supposed to sum the quality after it is sorted. So I messed that up. Or after it's sorted by this thing. I think. Maybe not. Maybe I'm just like really. I thought I had it, but then maybe I'm just like really weird. Alright, let's just. Clearly, I do not know what's going on anymore. And cannot even type. Is that better? I was just trying to do a quick shortcut, but did I misunderstand this? What was I trying to do? Okay, no, it's 17. But no, if you sort it, it's gonna be 1617 and 2/5, right? 16 is bigger than 17, Larry. Okay, fine. But then the limiting factor should then be 16. So 16 times, why is it, okay, this, but then what is the total quality? Why is that so off? $10? Oh. No, this I need it. Okay. Okay, 15. Each of these oh, did I do the, maybe I messed up the signs. I mean, it's still wrong, but it's because for some reason it is this, but am I thinking about it wrong? Isn't that the limiting factor? Total quality is 15. The minimum is going to be the limiting factor, is it not? No. I thought I thought I had it, but I'm just being dumb. I think. I mean, I think some part of the idea makes sense, but here it does clearly does not. What am I doing? 0.75 is the third one. That doesn't make sense. Oh, because this is now that, then we're limited by the biggest element, which makes sense. But then I think I'm just doing it weirdly. Okay, maybe I can't do it quite like this because I think that part of the greedy doesn't make sense. Because I think I reversed the order of some. Because I thought the ratio would be multiplied, so I think I messed something up. Okay, let me reset very briefly. Because basically now we're saying, okay, let's say we have 10. We have 10 and 5, 70 and 30. Why? So the limiting factor is the thing that costs the most, which is the lowest. So in this case, it will be the smallest ratio, right? But we don't have to have this number, right? So, okay, but let's say we add in 2050. Why is that no bueno? Because basically now, what we care about is total quality, right? Because then now, let's say we have a heap, we have 116, and once we have a min heap, so then this is the smallest, and 2/5 we add it on, but we're like, no, this is no good. Maybe I still don't get it. I think maybe I messed something up. Sorry, friends. I had a incorrect start. Thought I had it, but this is just wrong. Okay. Let me. I think the hardest thing to do in a problem is to reset your brain. So let me try to do that real quick. We need to keep this, and then let's try again. Oh man, this is rough. All right. Then now we have 3/4, 1/8, 5, 5, and 1/7, right? And basically what we said is that the lowest ratio is going to be the most expensive. So then what does that mean? That means that, okay, I get it, maybe. So now the lowest is going to be the most expensive. So maybe we just flip it, but it doesn't matter. It's the same idea. I see. Then now we can brute force. That's the way to do it. Because then now, okay, first we sort by this stuff so that everything before we already assume has a higher ratio but costs less per quality, right? Yeah. And then and then from that's how you piece it together. I'm not very smart today. Because then from that, then you just take the case smallest quality and then do it that way. Okay, so in that way it becomes like a brute force. Okay, fine. Alright, so I guess we have to write the same thing, but it's fine. Which way do I want to do it again? I think it's this. Let me print out buckets real quick. I think maybe the other way actually. Yeah, I want it the other way. I mean, that's fine. I can also just reverse it. But then the idea here is that we're basically doing the cheapest, like the current quality over wage is, so basically now we do something like this, right? So, okay, yeah. This is a hard one. Right, so then now we go, okay, so bucket sub I of 0 over, I forget which direction it is the current cost for quality over wage. Maybe the other way around. I don't know. So best is equal to, I don't know, something really big. And then now we want to get the max. Basically, now that this is the cost per quality, given, this is the cost per quality. So then now we're trying to minimize the number of the total sum of the quality that we have, right? So yeah, so then now we use a heap, maybe total quality, and then now we have H is going to be heap, and yeah, okay, and then now we go total quality, we add it to bucket sub I sub 0, which is the quality, okay, and then we put it into the heap, and then we want to remove the max actually, so we want this to be a max heap. The reason why we want to remove the max is because we want to keep the things inside the heap as small as possible, so when you greedily just subtract the biggest number, that'll be good. In Python, there's no max heaps that I know of easily. Let me know if I'm wrong. So I'm just going to convert this to negative, right? And then, okay, so then now while length of heap is greater than k, that means that we have more than k workers, so we can now subtract stuff. We can pop h. So this is the top, and it's already negative, so then now total quality subtract from top, right? So then now we have k items. So with length of h is equal to k, then we have k workers, and what is the cost of hiring them? Well, this is the cost per quality over wage, maybe. Is either that or the other way around? I've been confusing myself. No, it's what did I say? This should be quality over wage. So if we have, I think it's the other way around. That's why this is confusing. Yeah, wage over quality, and then now we have total quality. That's times this. It's going to be the cost, right? Because this is the wage per quality, and then we add it to cost, and then cost is equal to this, and then we just min it over best is min. All right, and I think that's good. Alright, I think that makes sense now. Greedy is so hard to prove, that's why I get it wrong all the time. But this is a different type of greedy. This is more like a heap thing. So I'm rubbing my eyes around a lot because of allergies. My apologies. And apparently the last time I saw this was 5 years ago. I wonder if I struggled with it that time. But yeah, it's not an easy problem. Definitely a lot of things you have to play around with. As you can see, I don't remember, and I in fact got it incorrectly for about 20 minutes. But you have to be able to you have to play around with these prompts. You have to play around with it. You have to look at these examples, try to figure out what makes it click. And for me, the thing that finally made sense was that basically, yeah. How do I say this? Basically, given these array, right? Basically, given these array, the idea is that, and I finally put it the other way, is that this is the cost per quality. But if you sort them in a way such that is increasing, that means that all the workers that you've seen before already has a lower wage per quality, so that's no longer the limiting factor. The limiting because now buckets have increasing. I mean, I kind of did a reverse because I sorted by the wrong thing. Maybe I should rewrite this a little bit, right? Just to be more clear. So then now you have wage per quality, right? And that means that every worker that you've seen before has a better wage per quality, but then it just depends on, like, the only question is how much quality there is, and in a greedy kind of way, you want to choose the cheapest quality, and this is why we have a max heap to kick out the things that are cheapest, and we have a total quality to keep track of the sum of quality that's inside the heap, and that's pretty much it. You have to establish this monotonicity going up so that when you go left to right, every worker that you already considered, the only thing that you care about is their quality after that, right? Because there's no longer the limiting factor because someone else is more expensive, or it's going to make the total wage more expensive. That's pretty much what I have for this one. This is actually nlog k, right? Actually, I lied because of this sorting. Yeah, yeah. I'm trying to think whether I need this sorting, but I think we do. Can I do it more incrementally? I think you actually could. I think you actually could do this in nlog k. By instead of using, well, obviously instead of sorting the whole thing, you use another heap that keeps track of the ratios, and then the top ratio, I think, but it's a mess. So I don't know, but I think you can do an nlog k, but this is nlog n, even though this is nlog k. So that's what I have for this one. Let me know what you think. Thanks for watching. I'll try to solve another problem to this after this. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.